Today's story begins with a dream. Not the dream of robots taking over the world, and not even the dream of machines replacing people. It begins with something more ambitious and more human. The belief that intelligence itself could be understood, broken into parts, and rebuilt in a machine. From rule-based expert systems to modern chatbots that can write essays, answer questions, and hold a conversation, artificial intelligence has traveled a long and winding road. It has passed through waves of excitement, disappointment, reinvention, and hype. At each stage, people have asked the same question in different forms: can a machine really think? This is the history of artificial intelligence, from expert systems to ChatGPT. To understand modern AI, we need to go back to the middle of the 20th century, when computers were still enormous, rare, and mysterious. In the 1950s, a small group of mathematicians, computer scientists, and cognitive researchers began to imagine that thinking itself might be simulated. If the human mind followed patterns, and if reasoning could be described logically, then perhaps a computer could do it too. This idea became one of the foundations of artificial intelligence as a field. Researchers believed that intelligence was, at least in part, a matter of symbol manipulation. In other words, maybe thinking was less like magic and more like following rules. That mattered because early computers were very good at rules. If you could describe a problem clearly enough, a machine could process it step by step. So researchers began building programs that solved puzzles, proved mathematical theorems, and played simple games. These systems were limited, but they were impressive enough to create a powerful sense of possibility. AI, in its earliest form, was less about language and personality than about logic. The hope was that once you taught a machine the rules of reasoning, general intelligence would follow. It did not. But that early optimism shaped everything that came next. By the 1970s and 1980s, AI entered one of its first commercially important phases, the era of expert systems. Expert systems were built on a simple but powerful idea. If human experts made decisions by using specialized knowledge, then maybe that knowledge could be collected into a large set of rules. So, instead of creating a machine that thought like a person in a broad sense, researchers tried to build a machine that could reason like an expert in a narrow field. A medical expert system, for example, might ask about symptoms and use a chain of if-then rules to suggest a diagnosis. A system for geology might help identify mineral deposits. A business system might help with credit decisions or equipment troubleshooting. These programs were not intelligent in the modern pop culture sense. They did not learn from experience. They did not understand language naturally. They did not improvise. But in specific domains, they could be remarkably useful. For a time, expert systems looked like the future of AI. Companies invested in them. Universities trained people to build them. The promise was clear. Capture expert knowledge once, then scale it. It sounded revolutionary, and in some ways it was. But expert systems had a weakness that would become impossible to ignore. They depended on humans to write the rules. Every rule had to be added, tested, and maintained. Every exception had to be anticipated. Every new situation risked breaking the model. And real life, as it turns out, is full of messy exceptions. Human knowledge is often intuitive, contextual, and hard to express in neat, logical steps. Experts know things they cannot always fully explain. Once AI researchers tried to turn that into thousands of formal rules, the systems became difficult to update and brittle in practice. They could perform well inside the world they were designed for. Outside it, they struggled. Like many technologies before it, AI then ran into disappointment. When progress failed to match expectations, funding dried up. Interest cooled. Critics became louder. This period became known as an AI winter. In fact, there was more than one AI winter. These downturns matter because they remind us that the history of AI is not a straight line of improvement. It is a cycle of belief and doubt. At several moments, people thought truly intelligent machines were just around the corner. Then they discovered how hard intelligence really is. Early systems could perform beautifully in controlled settings, but the world is not a controlled setting. Language is ambiguous. Vision is messy. Common sense is hard. Context changes everything. A machine can follow rules perfectly and still miss the point. By the late 20th century, AI had a reputation problem. It was still alive as a research field, but its grandest claims seemed less convincing. The dream had not died, but it had become humbler. That humility opened the door to a very different approach. The next major shift in AI history was profound. Instead of telling machines exactly what rules to follow, researchers began focusing more seriously on teaching machines to learn from data. This changed the center of gravity in AI. In the expert system era, intelligence meant encoded knowledge. In the machine learning era, intelligence increasingly meant pattern recognition. Rather than writing out every rule for identifying a cat in an image or detecting fraud in financial records, engineers could train a model on many examples and let it discover statistical relationships on its own. This approach had been explored earlier, but it became much more powerful when three things came together. First, there was more digital data. Second, computers became much faster. Third, researchers improved methods for training large models. This was a turning point. The question was no longer only, how do we describe intelligence? It became, how do we build systems that improve through experience? Machine learning proved especially effective in areas where explicit rules were hard to write, but examples were plentiful. Speech recognition improved. Recommendation systems got better. Search engines became smarter. Spam filters became more reliable. AI was becoming useful, not because it fully understood the world, but because it was getting very good at finding patterns inside it. Then came deep learning. Deep learning is, in broad terms, a way of using multi-layered neural networks to learn complex patterns from enormous amounts of data. The idea of neural networks had existed for decades, inspired loosely by the structure of the brain. But for a long time they were limited by computation and data. When those constraints began to ease, the field changed quickly. Deep learning systems achieved dramatic gains in image recognition, speech processing, and translation. Suddenly, tasks that once seemed stubbornly difficult became newly tractable. Computers got better at recognizing faces, transcribing speech, translating text, and generating plausible outputs. AI stopped feeling like a specialized research topic and started becoming part of everyday digital life. This was also the era when public perception of AI began shifting again. People were no longer just hearing that AI might matter one day. They were seeing it show up in their phones, feeds, maps, cameras, and online platforms. Still, one major frontier remained especially challenging: language. Human language is slippery. Words change meaning with tone, culture, and context. We imply more than we say. We refer back to earlier ideas. We play with irony, rhythm, metaphor, and omission. For a machine, language is not just vocabulary. It is structure, memory, relationship, and prediction all at once. And yet, language would become the arena where AI made its most culturally visible leap. A major breakthrough came with a model architecture called the transformer. Without getting too technical, transformers made it much easier for AI systems to process relationships between words across long passages of text. Earlier, systems often struggled to retain context efficiently. Transformers improved that. This mattered because language depends on context. A sentence is not just a row of words. Each word changes meaning depending on what came before and what comes after. With transformers, researchers could train much larger language models on vast amounts of text. These systems learn to predict the next word in a sequence with astonishing fluency. And when models become very good at next word prediction across enough data, something surprising happens. They begin to produce writing that feels coherent, informed, and at times uncannily human. Not because they are human, not because they understand in the same way we do, but because language itself contains deep patterns, and these models became extraordinarily good at capturing them. This set the stage for the GPT family of models, and eventually the public release of ChatGPT. When ChatGPT arrived, it did something many earlier AI systems had failed to do. It gave millions of people a direct experience of modern artificial intelligence. You did not need to read a technical paper. You did not need to work in a lab. You only had to type a question. And suddenly, the history of AI became personal. People asked it to explain homework, draft emails, write poems, summarize documents, generate code, brainstorm ideas, and imitate styles. For many users, it felt like the first AI tool that was not hidden behind another product. It was the product. That visibility changed the public conversation. For decades, AI had often been discussed in abstract terms, either as a miracle or a threat. ChatGPT made it immediate. It showed people both the promise and the limits in real time. The promise was obvious: speed, accessibility, creativity, and scale. The limits were obvious too: inaccuracy, fabricated information, shallow reasoning in some contexts, bias inherited from data, and the strange fact that a system can sound confident without actually knowing. That tension is central to the current chapter of AI history. ChatGPT did not appear from nowhere. It was built on decades of work in symbolic reasoning, expert systems, machine learning, neural networks, large-scale computing, and language model research. In a sense, it represents both a break from the past and a return to one of AI's oldest ambitions. The break is in method. The return is in aspiration. Once again, people are asking whether we are finally approaching general intelligence, or merely building better tools that imitate parts of it. Looking back, one of the most striking things about AI history is how often the field changed its mind about what intelligence is. At first, intelligence looked like logic. Then, it looked like expertise. Then, it looked like learning. Then, it looked like pattern extraction at scale. Now, to many people, it looks like conversation. But each stage reveals only part of the picture. Expert systems taught us that knowledge can be formalized, but only up to a point. Machine learning taught us that data can outperform handwritten rules. Deep learning showed that scale can unlock surprising capabilities. ChatGPT showed that language itself can be a powerful interface for intelligence. And yet one lesson repeats across the decades. Performing intelligence is not the same as possessing human understanding. That does not make the achievement small. In fact, it may make it more historically interesting. AI has advanced not by copying the human mind exactly, but by finding different computational routes to useful outcomes. An airplane does not flap like a bird, yet it flies. In much the same way, AI does not think like a human, yet it can perform tasks that once seemed to require human thought. That difference matters. It shapes the ethics, the economics, and the expectations. So where does this history leave us? At a threshold, probably. AI is now embedded in education, design, medicine, finance, programming, customer service, research, and entertainment. Governments are trying to regulate it. Companies are racing to scale it. Workers are wondering how it will change their jobs. Schools are rethinking what learning and assessment should look like in an age of machine-generated writing. Historians may one day say that the age of ChatGPT was the moment AI stopped being a future idea and became a social fact. But history also warns against easy certainty. Every generation believes it is witnessing the final breakthrough. So far, every generation has been wrong. The more useful question may not be, is this true artificial intelligence? It may be, what kind of intelligence have we built? What can it actually do? And how will it change the way humans live? Because the history of AI is not just the history of machines becoming more capable. It is the history of humans redefining what counts as thought, skill, creativity, and expertise. What started with expert systems and rulebooks has become something far stranger. Machines that generate language, mimic conversation, and participate in daily life at a scale early AI researchers could only imagine. Whether this is the beginning of a new era or another peak before the next correction, one thing is certain. Artificial intelligence has a history, and that history is still being written.